get multiple accelerations, and how are we going to do that? We're going to have multiple heights. Some groups are going to be on the bottom arm, some groups will be on the seat, and some groups are going to be all the way to the top of the back of the seat. Now, one problem you may have is if the ramp bows, that's a problem. You got to support it. And no matter at what height, you always need to support it. A lot of people want to put the support there, but I actually still see a bow, so you put it a little bit farther. Now I see it going straight down. So again, we have the timers and the ramp. I ran this with just 4 students to a group because I didn't need the floor space. And I have them count down, 3, 2, 1, start, stop. And you have 3 timers doing that. Start, stop, and so on until you get your 5 data points. Now, we're going to have to be a little more careful about the data this time because we don't want them to be able to get a straight line, so our error bars need to be a little smaller. And we want to use the simplest quadratic, y equals ax squared. B and c need to be changed to 0, which is nice, because then when they put in the a values, they learn that the a value controls the upswoopiness. And that's good, because going into the board meeting, they're going to notice everyone has quadratic, but different levels of upswooping. And then they start connecting. All the ramps with a high starting height have the steepest upswoopiness. And they're going to want to say that that's because the ball is going faster. In every ramp, the ball goes faster. We want to lead them to that what's different about the steeper ramps is that it speeds up quicker. And then we're going to seal the deal because we're going to go back with the Logger Pro still open. We'll turn on interpolate and then tangent and go back to the 5 data points they took and find the slope at those 5 points and make a new graph. The instructions are in the PowerPoint called velocity versus time, and they get a linear relationship. And then we, of course, can display both graphs at the same time, and they see the a value is 1/2 of this slope, and they know this slope is acceleration from the rate of the change of